Same rolling.
Yeah.
Don't show up. Do whatever.
All rolling.
Didn't watch the blasphemous.
Okay, so I want to talk about a couple of things with electronics for a minute. And then for those of you that need it, I'll do a quick soldering lesson. I don't advertise myself as a pro solderer, but even if you've done it before, I might be able to show you a couple things. I've done a bit of soldering. And then we'll get back into assembly of your robots. And I posted a link to the Discord that's got a video that walks you through the wiring process of getting hooked up to the motors. I mean, there's a certain amount of latitude with how you hook up the motors to the Pi, but if you hook it up the way I described in the video, then the code sample that I have up on GitHub will work, and you won't have to change all the pins around, so it saves you a step there. But anyway, I want to talk about switching, and when I say switching, what I mean is the ability to turn things on and off digitally with the Raspberry Pi. There's a lot of stuff that we can explore in the next few weeks with electronics and the Raspberry Pi, but switching things on and off in terms of robotics is a pretty important basic building block. And just if you haven't dabbled much with electronics before, I just want to talk through a couple of things to get some ideas in your head so you understand. I don't want there to be like any mystery, any black boxes for what's going on here. Because when you hook up the robots with the Pi, turning the, those little stepper motors on and off, there's the controller chip, the controller boards in the middle there. I want you to understand basically what's going on there. Again, so there's no mysteries, and then so hopefully you can kind of apply those ideas to other projects in the future. Again, the idea is not to build this robot. The idea is to build a set of skills with you guys that you can use to build any robot you want to build. So that's why these concepts are important. So anyway, switching things on and off. Is there anybody here who's dabbled with electronics and built things like little electronic circuits or things like that before? Okay, so you've probably seen the most basic switching example, which is the old mechanical switch, where you've got, I know, right? Except this is a color-changing LED, so that makes it extra. It's RGB, right? And I know how you kids are these days with your RGB, but this is about the simplest example. You've got a battery, a literal mechanical switch, right, to turn it on and off, an LED. I've got a resistor in line because I'm a good doobie. And we won't get too deep into the details here, but generally speaking, when you're using LEDs, you need to have a resistor to limit the current. That's a conversation for another day. In any case, you can turn the switch off and you break the circuit, and electrons are no longer flowing from the battery through the wires to the LED and back around again. Circuit, right? Circuit, right? When you turn the switch, I've got a loose connection there, but when you turn the switch on, the electrons flow and the light lights up. All right, so that's sort of like the most basic example, right? Moving up from there, though, you've got a big limitation, which is that it's kind of hard to get a Raspberry Pi to flip the switch, right? Like, I mean, you could have a servo, I guess, but like moving the servo is at least as complicated as, So flipping the switch with a Raspberry Pi, that's not going to work, right? So the next example kind of up from that would be a relay, which Jack is helpfully holding in his hands right there. Has anybody heard of a relay before? You know what a relay does? Anybody want to tell me what a relay does? Sorry, say that a little louder.
Uses a magnet to flip a mechanical switch.
Yes. So the name for that would be an electromechanical switch. You can probably guess why. So this one came out of, I think, a switching power supply in an old piece of hi-fi equipment or something like that. It's a 24-volt relay, which is kind of it's larger than we usually use. But like Jorgen was saying, if we power this thing up, you can hear the click as the magnet actuates and closes the switch, right? So by applying enough current and enough volts to energize a magnet, it pulls the switch closed and closes the contacts. So we could wire this up just like we did over here, and when we apply power to the electromagnet, it would close the switch and it would turn the LED on, right? So we're getting closer to where we want to be here. right? Applying an electrical signal, like from something like a Raspberry Pi, to turn something on and off. But what's the problem here? Why isn't this going to work with a Raspberry Pi? Any thoughts?
Watt of power.
Yeah, right. We're not going to push 24 volts, at least not directly, from a Raspberry Pi. On a Raspberry Pi, at least, as it comes kind of to us from the factory, you've got a 3.3 volt output and like a limit of like 50 milliamps or something like that. And then a 5 volt output with a limit, it depends on the power supply, but like an amp or an amp and a half.
Can we stick that through a Raspberry Pi? Can we create that, the 20 volt?
Can we use this battery that is probably the equivalent weight of about 25 Raspberry Pis or more?
Create a fire?
Yes. Let's not do that, right? Okay, so we're going in the right direction here, but we don't want to drive something with this kind of power requirements from a Raspberry Pi.
So why would we want to use a relay? What's the purpose?
Well, actually, that's why I chose this image. This is sort of a relatable example here, okay? And thank you for asking that question, because I would have forgotten to talk about it. So in this example, this is like the headlights in a car, okay? Now, the headlights in your car actually draw a lot of amps, a lot of current, okay? Big bright lights, especially older cars like with incandescent bulbs in the front. And so to switch that on and off, you need a switch that is rated to move that kind of current, which is not a trivial thing, right? Like the switch that's actually on like the steering wheel stock thing is closer to like this kind of switch, right? And you're not going to push like 15 or 20 amps through that switch, right? So relays with these big copper contacts are really burly. This can switch that kind of load on and off very easily, okay? The other thing is that a lot of times in a car, you have the headlights and the relay and the battery all near each other, right? The headlight relay a lot of times is next to the headlights or in a box under the hood. Not always, but a lot of times. And so if you arrange something like a small switch on the steering column to switch a relatively small current to energize the electromagnet, which is closing the big switch that's turning the lights on and off, then that's safer because you're not running that high amperage current up through the steering wheel where your hand's going to be. And you can have, it's also a cost-saving measure because you can have shorter runs of the high-gauge wire that's going to handle all that current under the hood and not have to run it all the way back to the steering column. So there's a few different reasons. Safety, cost-cutting measure, it's more efficient. So that's why these things are used to switch high current loads on and off, and you can use a...
If we had a smaller one,
Yeah.
we could use the Pi
Yes.
to do that.
Yes, you could do that. Yes.
But not the other way around. This is meant for much more.
Yep. Now, there's another downside to this for our purposes. You want to take a guess on what it might be?
Chunky cost a bunch.
Yes, that's a good one. Not what I was thinking of, but yes, that is an important one. These are not cheap, right? What I was thinking of is that these are slow, right? Relatively speaking. Even if you're firing it as fast as you can, it would kind of like make like a buzzing sound, right? But compared to the next thing we're going to talk about, which can switch thousands and thousands of times per second, this thing's freaking slow, right? So the next option is the humble transistor. So transistors, I wanted to talk about these today because transistors is what we're really going to be dealing with in one way or another when we're switching things on and off with a Raspberry Pi, whether we know it or not. There's actually transistors inside the Raspberry Pi, so whether you wanted to use transistors or not, you're still using transistors. But basically what's going on here is the transistor is also an electrical switch, or can be used as one. Transistors can actually be used for a lot of things. But one of the common uses is as a switch. In the same way as a relay, but there's no moving parts, right? It's all about using electrons in interesting and creative ways to turn on or off a current flow to switch something on and off. So if you'll pardon me standing in front of the screen here, basically, in the case of this style of transistor, it looks like this. There's one on the breadboard there. It's this tiny little thing, okay? If you have a very small current flowing in on the base and out through the emitter. So basically your signal comes in on the base and the emitter is grounded. When you're passing a small current through, what that does is those electrons energize or saturate the transistor and allow a much larger current flow through these connections here. And so that's illustrated with a sort of water analogy on the right here, where you get a small flow of electrons, but they're illustrating with water, coming in from the side. It's acting like a valve to allow a much larger flow of current. which also implies the other big use for transistors. That's also a larger conversation for another time, but transistors are used as amplifiers. So if you imagine a small signal, like an audio signal, coming in from the little thing on the right, causing variations over a much bigger current flowing through the other, the other couple of leads on a transistor, that's how they're used for amplifying audio signals in like hi-fi equipment and things like that. But in our case, we're using it as a binary state, right? Off, nothing flowing, closing that gate, and then energized or on, open, and it's allowing current to flow. So to illustrate that, what I've got is I've got a high power LED. This is like a 1 watt or 3 watt LED, and a driver to make it go. And the driver runs on 4 volts or something like that. Now we couldn't drive. This LED is consuming something like 500 milliamps of current, so half an amp. It would not be recommended that you try to drive that directly from a Raspberry Pi. Technically, you might be able to do it off the 5-volt rail, but generally speaking, if you're driving a big load from the Raspberry Pi, you want to switch it. You don't want to try to drive it directly from the Raspberry Pi. So in this case, we've got the battery, and we've kind of split the power. It's going through, or in a minute when I connect it, it's going to go through a resistor that's going to limit down to a very small amount of current what's flowing into the base. That's going to kind of open the valve, and it's going to allow the battery to power the driver and the LED. So you might not want to look at it directly. It's a little bright. It's not going to light it on. Oh, there we go.
Oh, okay.
Right. I mean,
Don't be scared that you're
no, I don't mean it's going to it's not like a flash grenade or something like that. But so in this case, it would be really trivial to use the Raspberry Pi. Actually, this illustration is not a totally accurate depiction of what's going on here. I'm actually using, this is a NPN transistor. I'm using the other kind, which means the flow's reversed. But in the case of the Raspberry Pi, you could connect.
So it's opposite. So when it's
basically what I'm doing is I'm grounding out the resistor here. Yeah. So if I had, in this case, the Raspberry Pi, this wire was connected to one of the ground connections on the Pi. This was connected to one of the I/O pins. You set the I/O pin low in code, which connects it to ground. It would complete the circuit and turn the LED on. But the high current load that's going into, it's a heatsink. It gets warm if you don't have it, and that shortens the life of the LED. So if you keep it cool, they last longer. You get 30,000 hours of life out of an LED if you keep it cool, and it shortens significantly if you run it over temperature or over current. So anyway, so that's an example of using a transistor as a switch to turn a high current load on and off, right? Are we sort of on the same page here? So if you extend that analogy a little bit further, and instead of driving something like an LED, you want to drive something like a powerful motor, like a DC motor or something like that, you can do that with this sort of arrangement. So there's 2 more examples I want to talk about. Maybe we'll come back to this one, actually. Let's talk about, let's talk about this one. So don't worry about the fancy title. A Darlington array is really just 2 transistors cascading together. So one is amplifying the signal, and then a second one is taking that amplified signal and amplifying it further. You can read the wiki article on it if you want to learn more about it. But the little chip that's on the driver board for the stepper motors that we're using is a Darlington array. Okay? The chip is actually capable of switching or providing 8 outputs. These boards are only using 4, so it's only using half the chip, but they're so cheap that, whatever. And basically, we're providing voltage into the chip, and then the Raspberry Pi is just sending a very small current signal into one of the 4 inputs, which then energizes one of the 4 coils on the stepper motor that's connected to the chip. So as you pulse input 1, 2, 3, 4, it's energizing in sequence the coils inside the stepper motor and moving it one little step at a time. So when we finally get these motors moving around and you see them move, what the Pi is actually doing is pulsing that motor and forcing it around in precise little movements, right? So if you run it in sequence, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, you get continuous, sort of roughly continuous rotation. It's actually steppy. It's kind of jaggy. But
so those will never get smooth rotation.
Well, there's a gearbox, so they get pretty smooth, and they're also relatively slow. But that's later. We're coming to that. But what steppers are really good for, especially in robotics, is you can do very precise movements, right? If you want to go, from a precise location here to a precise location here, and you know how many degrees of movement that is, you can move a very specific number of steps and go to that position. 3D printers that need to move in very precise, measured, movements, they use stepper motors to control that movement. And there's stepper drivers and a little processor, not unlike the Raspberry Pi, that's controlling all of that and providing the instructions. So servo, now you're getting into sort of like a Venn diagram of overlapping areas, right? A servo is just a motor that has some sort of feedback mechanism that tells you what position it's in, right? So that can be like a little RC servo, like in a toy airplane or steering in an RC car, where it has like a range of motion and you say, go to 30 degrees or go to 70 degrees. But a servo can also be a DC motor that has continuous rotation that's got a thing stuck on the back that tells you what degree position out of 360 or whatever it's in. It's really, servo can be many different types of motors, but they have to have a feedback mechanism that tells you where it is. Okay, does that make sense? So a servo could be something like a stepper or like a DC motor, or probably it could be a brushless motor, as long as it's got something on the back of it that's going to give you that positional awareness. Good question. Okay, so Darlington array is what we've got here. We're using it to drive a stepper, but you could use it to drive anything that needs a higher current signal that you want to pulse, right? So you don't have to use that chip just to control the stepper. You could use it for other things. Again, building blocks. Okay, and then the H-bridge. This is my favorite. Okay, so we talked about transistors, right? These are just transistors here. Okay, age-old problem. If you've got a DC motor, right? And by DC motor, I mean one of those little motors you hook up to a battery and it just spins, right? Toy cars, all that kind of thing. If you hook up a DC motor to drive your little robot around, right? What do you do when you want to make it go in reverse, right? You can make a DC motor go in reverse just by swapping the wires. But how do you do that digitally, right? That's a bit of a trick, right? So somebody came up with the H-bridge, and that's what it does, right? Why is it called an H-bridge? Yes, it looks like an H. But it's got 4 transistors, okay? And when you energize this one and this one, the current can flow from the power source through the motor in this direction back to ground. It's completely runs in one direction. If you turn those off and energize these, the current runs in the opposite direction. So you've reversed the motor direction, and it's all digital, right? So with an H-bridge like this, you can have 4 outputs from your Raspberry Pi going to the 4 transistors, and by setting them high or low in different combinations, you can make the motor run one way or the other way, okay? You remember the little mini-bot that we were driving around on the camera last week? That's using an H-bridge with 2 DC motors to drive around, and that's why that thing moves faster than these Q-bots, which are using geared stepper motors, okay? So does that kind of make sense? You don't have to instantly know how to use H-bridges and Darlington arrays and all of that. The most important thing, in my opinion, is that you know these things exist and what they can be used for. Because you guys can go read wiki articles or go on raspberrypi.org in the forums and figure out how to do this stuff. You don't need me to be the gatekeeper of that. I just want you guys to know that this stuff exists so you can go and figure out how to use it when you need to later. All right? Okay, so that's the little electronics thing. I'm going to turn my little color changing LED off now. Okay, so who wants a soldering demo? Yeah? Have you soldered before?
No.
Okay, come learn how to solder. I apologize to anybody watching the stream. I'm going to be out of shot of the camera for a while.
Pick the camera up, take the camera.
It is sticky note, or it is double-sided taped to the wall, so it's just staying there. Yeah, but to anybody on the stream, I will wave the results of what we do in front of the camera in a minute. Okay, so are you guys set, or do you want to?
Yeah, I got it.
Okay, I don't know if that's the right bit or not. Okay, let's see if this is nice and hot or not. Yes, that is nice and hot.
Is that just steel wool?
That is actually brass wool, so it's soft enough that it won't disrupt the coating on the tip. If you use something abrasive like sandpaper, then the coating comes off and the tips start corroding very quickly. Okay, so basically the whole idea of soldering is just joining 2 metals together so you've got a good electrical connection. And we're using a second type of metal, in this case a low temperature melting solder, the actual solder, to join them together. Okay? So the whole principle is very straightforward. But the things you have to remember about soldering are keep the tip of the iron clean. Okay? This is not too bad, but if it starts looking crusty like the stuff down here, you got to clean it off. A crusty soldering iron will not transfer heat well. And getting good solder joints and soldering quickly and efficiently is all about transferring heat quickly. Okay? So we keep the tip of the iron clean, right? Shiny. Put a little fresh solder on the tip there. And that little blob of freshly melted solder will, what's up? These are the wrong kind of headers. There's another one in the drawers over there. Yes. This one's mine. So fresh solder on the tip will also help heat to transfer quickly, so keep a little bit of fresh solder on the tip, okay?
And you were saying how much was on the tip there?
Yeah.
Like, was that a fair amount?
I mean, that's going to be sort of a feel thing. Like, whether you want a lot on the tip or just a little bit comes down to personal preference, and you'll get a feel for that over time. But you having trouble finding it?
Yes.
If you can't find it, look in there. Actually, look in the little toolbox that's down next to my desk that says Husky on it. It might be in there. So anyway, I was saying it's kind of a feel thing, like how much solder you want kind of blobbed on there. So I'm just going to stick these headers on here now. These are sort of similar to the Raspberry Pi, and I'll just solder a couple to kind of show you what it's like, and then you guys can try a couple. So I'm just going to throw this on here, and because I'm going to turn this upside down and solder the other side, I'm just going to use a piece of masking tape to hold this on temporarily. As soon as you get that first joint soldered on there, you don't need the tape anymore because all the pins are together. You still can't find it?
Yeah, it's fine.
Okay, I'll look in a minute, but let me just do this first part.
Okay. I can do without. It's fine.
Okay. There's also if there's a sponge in the drawer over there, like the little one, you can wet that in the bathroom and then and use that to wipe the tip of the iron off. Okay. So it's a little hard to see, but I've got a row of pins sticking up through the holes here, right? You can run your finger over there if you don't believe me. Okay? And basically, I was saying how a clean tip is important. The other thing is that if you look at the tip of the iron, there's a couple of flat spots. Like it's not perfectly conical. There's a flat side here and a flat side here. And the flat side, if you bring that in contact with what you're trying to heat up, the heat's going to transfer faster. Now, Jeff, why do you keep saying transfer the heat faster? Well, there's a couple reasons. First of all, if you want to solder quickly, you want the heat to transfer. And speed isn't everything, but if you're doing 40 pins in a row, like speed's kind of nice. But the other thing is that sometimes when you're soldering parts, some parts are temperature sensitive. And you don't want to be putting the iron on it and waiting 5 minutes for the thing to come up to temperature because then you're going to overheat the part and you could damage it, right? So the ideal situation is you get in there, heat the joint up, add the solder, and get out as quickly as possible, and then there's no chance really of you damaging anything, okay? So that's why I keep talking about heat transfer. Keep the tip clean, add some fresh solder, get in and solder the joint, put the flat side in to heat up what you're heating up, and then add the solder. Now, the other thing, as I mentioned, we're trying to heat up the pin, but also the ring around the pin. You need both of them hot so that the solder melts and joins all three of you get the ring, the solder, and the pin all joined together, okay? If you heat up the pin but not the ring, or the ring and not the pin, you can get what's called a cold solder joint, which means they're not all bonded together, and then you don't get a good electrical connection, right? So I'll add that little bit of solder here on the flat side of the iron. I'm going to bring it in, and I'm going to rest it on, I'll do one in the middle so you guys can all see. I'm going to rest it on both the ring and the pin at the same time. It takes a few seconds to heat up. Add a little bit of solder, okay? And what we get, because there's surface tension to the solder, I realize this is tiny, but you get something that looks kind of like a little mountain or like a Hershey's Kiss, right? It's like wide at the bottom and kind of flares up or flares down as it goes up, okay? If you completely cover the ring and you get that little flare, you've got a good joint. Okay. If you add too much solder, let me add too much. Actually, now that I've got that first one on there, I can pull this off. Because since they're all joined together, they won't fall off. Let me show you too much solder. That's too much solder, right? If you get a big ball sitting on top, yeah, that's too much. By the way, if you get too much, you can use this thing.
Oh, do you have a little pump?
Little solder sucker.
I only have a little like rubber one. I wanted one of the nicer automatic ones.
Yeah, just because it's liquid when you pull it off. Yeah, you get a little blob of solder there. So anyway, you do a couple of joints and solder joints, and the tip might get a little corroded. So remember, keep it clean, okay? But then, you know, if you get in there and you heat up the ring and the pin, it doesn't take very long, right? So if everything is working the way you want it to, the tip is clean, you get fresh solder, you get good contact between the pin and the ring, then you can kind of get in a rhythm. My hands are a little shaky tonight, but you know, you can get moving along pretty good here. If I was leaning on the desk and kind of bracing my elbows rather than floating up here in midair, you know. Right? You get going pretty good, you know? So let me get another pin header, and I got a couple left on the end. Actually, if you want to give those last like 5 a try. Oh, sorry, one more hint about this. This is a pretty good place to hold it, right? This is hot. Yeah. Don't put your hand on the metal parts, okay? Yeah. So give that a try, right? And let me get another set of pin headers, and we'll let the other two of you give it a go also.
Flex, but for the first time starting in a while, I think a few of them, this run right here, it's pretty clean.
That is pretty clean. Look at you.
Turn my hat on. Put my eyes.
You're all like, I don't mean to flex.
Not the flex right. I think soldering is one of the most satisfying repetitive tasks.
When you do it right.
How's it going?
Yeah, well, once you get into a
Feel all right?
you just like get really clean runs and stuff.
Yeah, those look good.
And then you sneeze or just mess everything up and you feel terrible.
Cool. Yeah, if that was on the back of your Raspberry Pi, those would all be totally acceptable. So let me throw, I actually had these.
What good do they need to be to have a solid connection?
You basically, what you're looking for is no gaps, right? So if you look in here and you can't see, I can't even know which end. I guess I did this. I'm not even sure which end I did. Anyway, it doesn't matter. But like if you don't see any part of the ring that's not covered, and it's not too blobby, and it looks solid, you're good to go. You know, I mean, really, those are the only sort of measures of how good it is good coverage and, you know, being reasonably sure that you heated the base metal and the pin up enough that everything flowed together. All right, so we'll hold this on with tape just to get it good. And Jane, you want to give it a try? Come on. Have no. There's really no consequence of you know, like doing a bad solder joint. It's like, you know, it's.
I mean, like every time I try something with something hot, I almost always burn myself.
Sure, I understand. So, you want to have good control over the iron, okay? And so I'm holding it like here, but like this ridge basically means like there's no real way for me to slip and get my hand over it to the hot bits. So this hand's pretty good, okay? And obviously you want to know where the iron is so you're not like, you know, burning your other hand. But my hands aren't always super steady, okay? So what I do is like if the row of pins is over here, and I don't want to be slipping around, I want to make sure that everything's nice and solid. I'll use my pinky on this hand to kind of brace it, so that the hand's, you know, nice and solid. And then I just give it a couple seconds for things to heat up. Yeah, the tip is dirty rather. Remember what I was saying before?
Yeah.
It took like a good 5 seconds for that to get hot enough.
You just stick like a pad
There you go, like that. You give it a try?
How many solder irons do we have?
There's the 2 that are out now, and then I've got mine is in there I could bring out if we needed it. I think we might have one more. So 3 or 4. Gordon, you want to give it a go? Sure. All right. Okay.
Oh,
wrench it in.
Okay.
It worked.
Okay, be careful not to crack the board though.
It's like a little bit.
Okay.
It threads nicely.
We have a small problem. What?
You burned the clamp.
You did what?
He burned the clamp.
Let me see.
We have a problem, Jerv.
What's that?
I've lost my one pin.
We'll just get another one.
Does anyone have one extra pin?
No, they come perfectly split.
Yeah, they come as 40 in a row. So
Feel bad.
I don't know that I can help you with that. So where did the clamp get burnt? It can't have been that bad if I can't see it.
Yeah, I think
Oh, there? No, that's all right.
Where do we do this?
They haven't moved.
They're in the same spot.
I don't know where they were to begin with.
You could look in there. There might be like the remnants of
Oh yeah.
the previous one. Yeah, like, is this the same? Yeah, just break one off of that. Try needle-nose pliers.
I feel that. I don't think my
Blow up a capacitor when his arm was over it.
Is this the one that?
Mark on his hand.
I think so, at least.
Oh, it looks like it. It looks like the tip got damaged. Yeah, it looks like I need a new 1/8" drill bit.
We use Tech Edge, Tech Edge live like woodshop, their drill bits, and it sucks for the woodwork on there.
Are they like not in good shape?
Yeah, they're not in good shape, and I mean, we've gotten metal bits now, but our first year we were using wood bits on metal.
Mhm.
So
Oh yeah, that's a little rough. You get away with that with like aluminum or something, but you know anything much tougher than that.
we were using aluminum.
How's that?
Those look great. That is
It's cool.
perfectly acceptable.
So
Yeah. So you need a set of headers.
Do we have a working bit?
Are you see?
Sort of. Yep. Yep.
It definitely doesn't have to touch the plastic.
No, it doesn't.
I finally got the extra bits.
Nice. Good job.
I'm going to the bathroom now.
In celebration.
Oh yeah, you missed out on when you were teaching. He would like do a bunch of the handle, and then he just like put his head to his hands and erase it.
I blundered again.
Tell me your struggles.
I did my singular pin.
Yeah.
But the problem is the pieces of plastic are just
See?
too thick.
Sure.
So I just need to kind of trim it down a little bit.
Yeah, that'll be okay.
What? I don't know.
It's a little bit more difficult because the part that's too big is the part that's already in there.
Yeah.
But maybe an X-Acto knife.
Yeah, that's my thought.
Can you use that without injuring yourself?
As I stab myself.
Wow. Yikes.
Can I use this one?
You certainly can. Yeah, it looks like I think that one's, that is a little bit too big, I think. That's the one with the damaged tip, but try it anyway. You might be able to get it to go through.
That's gone with the wind.
It is that. Gained sentience and walked away.
What's that?
I've ruined my fair share of things.
Yeah.
Just tried things.
All good? All right, so what do we want to do about your Raspberry Pi? So I can help you. But if you're going to wire it up, we got to get pin headers on there. Don't be afraid. It's just soldering. It's not surgery. It'll be okay.
Electronic surgery.
Sort of technically.
I would say desoldering is electronic.
Take that. So that's 40 pins. So you want two pieces of 20 and 20. So find the midpoint and give it a snap. Okay. And then get your Raspberry Pi, wherever it is. And as soon as the soldering iron frees up, we will figure out how to do this in a way that makes you comfortable. Like either
I don't know where my Raspberry Pi is.
it should be in your bin of parts.
Hey.
Yes.
Can I use your solder?
My solder? Oh, sure.
Solder.
I'm like, oh, we have to wait for it to heat up though.
It takes like 30 seconds. These irons are pretty good. Take that. And here, this solder is thinner, so you have to use more, but it melts real fast. Super fast. That's okay. You'll be fine. Sorry, what were you saying, Gordon?
Just force screw the bolt things.
Yeah, if you can't get the bit to go through, sure. Just don't crack the PCB. So yeah, the soldering of the pins will only take a minute, and then well, you got plenty done. You just got to get the wheels on there, and it doesn't make sense to mount the Pi until after you get the pin headers on there anyway. So, do you already have the nuts in the wheels, like the? Okay, so you want to put nuts in the nut traps, and then you can use little screws to hold them on the drive shafts, and you can attach these, and then as soon as that soldering iron frees up, we'll get your pin headers on there. Ooh, sorry. I bet that sounded great on microphone. Hope nobody's at home watching on headphones. It's all right, nobody's listening. we don't have any fans. Yeah. Sometimes Michael watches. Maybe Michael's watching. All right, so this one seems to be working. Okay, so why don't you get your Pi and your pin headers.
When I go to do the, what is this called?
Solder?
Solder. I go to do the solder.
Yeah.
Instead of actually going in the pin, it just goes up on the.
Okay, so clean the tip again so it's shiny. Put a little bit of fresh solder on there. Yep. Now use wherever that solder blob is. Press that against both the pin and the ring if you can. Yep, just like that. Now try adding the solder to the opposite side of the pin. Be patient. Yeah, it's taking a little bit. Okay, so we'll try a slightly different tactic. Okay, let me show you on one of them, and then you can do the rest. Okay. Sometimes you can't get like super good contact the way that you were doing it. So I'm going to take. What for? Oh, okay. There's a set right here in the drawer. So I've got a little blob of solder on the tip there. I'm actually going to hold the iron a little bit more vertical, right? So it's resting on the ring and on the pin. And then when I come in here, Okay.
Oh, okay.
Right.
All right.
And adding the solder on the opposite side from the iron kind of lets you make sure that both the pin and the ring are hot enough. Okay?
All right.
So give that a try.
This thing is actually like bending before it.
A little stiff? What do you say?
Oh, you might need to just unloose.
Oh, well, we could loosen it if we had more Allen wrenches. Oh, no joke. Too funny. That's better.
Yay.
Thank you.
Possible to play the video that you posted? up there?
The video.
The electronics that you were saying?
I can pull it up on the right screen
Oh.
if you guys want.
Sure.
It's just a thought.
Yeah, that's not a bad idea. Who said that? Did you say that? Yeah, go ahead.
You know, medic door problem.
Yeah. Way to step up.
Shut up, Fusion. Shut up. Shut up. That's not very nice.
Is it gonna cover, sort of talk about the process of wiring? And
Yes.
question here, you know, I barely got any bite on the nut on the other side, does it really matter?
As long as it's held on there, that's okay. But you could just use a longer screw. Yeah.
Right, I was just trying to fence that up. So it
Yeah.
seemed to- so you were sticking way out.
Right. Now, keep in mind that
I'm gonna
you.
have to solder this first,
Right.
so I shouldn't be melted on.
Well, you can, but you're just going to have to take it back off again.
Right, I was just sort of lining it. This-
Sure. Yeah.
Yeah, I got it in there.
Dote. It does have audio. Oh, hearing the sound of my own voice is so awkward. If you guys need wires, jumper wires, there is a selection of them up here.
Can't just use on without almost breaking it or breaking it.
So there's a little bit of a trick. Oh, you got it. You totally got it.
I didn't because I had to take a screw out because it wasn't long enough, and I just tried tightening it in for this one. Now it's like bulging up a little bit.
I think it'll be okay. Let me take a look. Don't panic. Oh, I see. Yeah, see how the hole doesn't totally line up? It needs to go in just a tiny bit further.
Yeah, but I don't understand how to get it to.
I'm here to help.
I'm like
So-
slamming it against the table. Not doing anything.
So needleless pliers work pretty well for this because what you can do is you can press against just the nut and not the wheel. So we'll just use that to press that up.
It's bending the table.
A little bit. The table will be okay. Is that what I sound like in real life?
Yeah, it's kind of tough to listen to, but we get through it.
Oh, ouch. Yeah, that's working okay now. So you probably don't need to screw that long, but they're lined up now. So you just get whatever screw you want to use. And,
Well, that's the second shortest screw.
okay. Well, it doesn't have to go all the way through the hole. It only needs to go into this.
No,
Oh, okay.
the shortest one doesn't work.
Oh, okay.
So we have to mount our own whole set of pins here?
Yeah.
Yes?
Yes.
Okay, where are those?
Hence the soldering.
The soldering?
Yeah.
That would make sense. Now so you bend them? How do you
You snap in half.
snap them in half?
So
to
there's
whatever you
there's
want?
40.
Oh.
There-
Hopefully you didn't fry a board
No, yeah,
there.
right. There's 40 of these, so just break it exactly in half, and that'll give you the 2 rows of 20 that you need.
Oh, okay, you just one side through and the other.
Yep.
So the long side, do I come up from the bottom, down from the
No,
top?
I would put the short side through the holes, and so you have the long side to put
Stick it
wires
up.
onto.
So as it go up,
Yep.
it goes up like that?
Yes. Yep. Okay, so do you want to take care of your headers and get that over with?
Oh, I was gonna put on the wheels now.
Okay, that's fine. But don't worry about the soldering. I'll help you with it if you're not comfortable with it. Do you guys hear that? That silence? That's the sound of robots being built.
Ooh, well, that was pretty gamer.
Comment.
Again. Don't mind me, I'm just sitting here cracking myself up. Uh-oh.
Mine need to go all like 4 inches.
I'm having it drag. It's gonna go this way.
No. So left over 1.
Hey, Drew.
Yeah.
I'm pretty sure that's other spider walker parts.
Graveyard.
Yep.
Is it one on the left side and then
Wait, is one on the inside or the outside?
I don't know. I'm sorry. I don't know what you're asking.
So on this,
Is this one or is the one closest to the memory card one?
The one closest to the memory card on the inside is 1. So it's 1, 2, 3, 4, 5, 6, 7, 8. Like that.
Not so
How you doing?
better. Yeah, I'm like more than halfway through.
Oh, yeah. You're doing great.
Yeah, this one.
You doing okay? Do you need help or you just need a minute to work through it?
Need to get used to it.
Yeah. That's what it's all about.
Jeff, you put these in very weird places.
Did I?
Yeah.
7, 11, 13, 15.
Those are all in a row on one side. How is that weird?
one of them is in the, one of them has a space, and then the others are right next to each other.
Yeah.
7-11 instead of 9-11.
Oh, that's because 9's a ground pin. Yeah, you could shift them all down if you wanted to. I think, I don't remember at the time, but when I originally built this, there were 3 stepper motors because there was one up front for a sensor. And so I think I tried to do all sets of 4 contiguous pins, but there just wasn't another set of 4, or it was something like that. It was one of those like not very good reasons, but it was still a reason.
21,
Something we'll talk about in one of the later classes too is when you start getting into like hooking up weird sensors and stuff like that to the Pi, You don't always use like straight I/O pins. Like, some of the I/O pins can literally be input or output, which is why they're called I/O pins. But there's some pins that have specialty functions. Like, what's that? Well, yeah, but there's also have you ever heard of I2C, which is it's a serial communication bus. And so basically, with I2C, you can have 6 or 8 or 12 devices all strung together like Christmas lights using only 4 wires. It's power, ground, and like a signal and clock or something like that. And so whatever it is, it's going to be okay.
Look at the pin.
Did you bend it?
Oh, yes.
What? That's fine.
The pin on the pie, though.
I'm not going to say that there's nothing you can totally screw up, but most things are recoverable. So don't stress about it. But anyway, so there's a few pins on the Raspberry Pi that are specifically for the I2C bus. There's a couple pins that are for the SPI bus, which is similar to I2C but has some different parameters. And then there's a few other things like that. So you can't just use all 40 pins for in and out. Like there's a few power pins, a bunch of ground pins.
Great. What else do we need to get the thing going?
Do you have it all wired up?
Yeah. Oh wait. Oh, I don't have that. Oh, I don't have Randy.
So that.
Right? So they both need individual 5 volts.
Well, so in the video, if you what. Yeah, so on the Raspberry Pi, you actually do have 2 5-volt pins and 6 ground pins. So you have enough. But if you use both 5-volt pins, you don't have any more for anything else you might want to add later on. So what I do in the video is I make a couple of splitter wires where I actually take 2 jumpers, well, actually 3 jumpers, and cut them in half and make 2 sets of wires that are like 1 wire on one side and a Y. So if you make 2 Ys, then you can use a single ground pin and a single 5-volt pin to power both steppers.
Okay.
So I would recommend doing that. I just told you why. Good? Yeah, it looks great. All right, so let's get the board soldering out of the way, and then you can just bolt the rest of it together. So yeah, bring those things over here. Can we share the scrubby thing?
You can share the scrubber thing.
Can you give me that big of a difference if I were to go 160/40 over?
No.
These aren't solid.
Okay, so like I did on the example board, I'm going to put these in and temporarily hold them in place with a piece of tape.
One of the hardest things about getting older is because go.
Remember that. Don't get old.
Enjoy your eyesight while you got it.
Don't get old.
Don't get old.
Okay. Yeah, that looks all right. Golly, I hope not. That would be terrible. It would be. Okay, so four options. One is you give it a try, and if you burn yourself, it's not the end of the world. But I think you could probably solder without burning yourself. Option 2 is we split the job up, and I do the soldering iron and you do the solder, or you do the soldering iron and I do the solder. And the third option is I solder the pin headers for you. I don't want you to do anything you don't want to do. Okay, cool. Do you want to sit or stand? Okay. Come right here. And actually, Gordon, can I steal some solder from you?
Absolutely. Oops.
Thank you. So soft I can rip it with my bare hands. Okay, so, yeah. All right, so just like before, let's just concentrate on getting 2 pins done because then we can take the tape off, okay? So take the iron. You don't have to grab it any further up than that, okay? Clean the tip off. With your other hand, hold the solder. And just put a little bit of solder on the tip of the iron so you've got a little fresh blob on there. Perfect. Now put that blob right on one of those. See if you can get it on both the ring and the pin at the same time. Any pin will do. Doesn't matter which one. Yep, hold it there for. Wow. Hey, look. You just soldered a solder joint.
Yeah.
Good job. Can you do the one over here next to it? If you do, like in this row over here, because if you do that one, then we can take the tape off. Yep, any of those will do. Melt that one again. So just go in there with the iron. Don't worry about this stuff. Just remelt that. You want to heat up both the pin and the ring. So get the iron in there on both and let it sit there for a second. Okay, now take it away. Yep, there you go. Now clean that blob off the end of the iron because you don't want that to get too messed up. Okay, so hold on. Before you do any more, let me get this tape out of the way. Okay. All right, do more. So heat the pin in the ring first, and then add the solder. Try to add the solder to the thing that you're trying to solder, not the iron. Yep, that's a little blobby, but that's okay. Oh, yeah, that worked. So just go down the line, and if you get any that are a little messy or a little blobby, we'll fix them after. That's great. That one was right on.
Yeah, I got a couple blobby ones.
Yeah, you get a couple that just have a little more than you need, but it's not going to hurt anything.
Okay.
It's really more a matter of like, they're not all perfectly identical.
Right, right.
If you don't care, don't worry about it.
But
This
as
one,
you get better, you
yeah, you get more regular about it. This one might be a little like a little shy on
need
solder,
another shot.
but I don't see any air. I think it's okay. I think it's great. Nice job. How you feeling? Is it stressing you out? Because you're doing a good job.
Is him asking you if it's stressing you
Yeah,
out? Stressing
right.
you out?
Should I not ask you things like if it's stressing you out?
Are you stressed out now?
Yeah. How about if I like poke you on the shoulder the whole time you're trying to solder? Would that help?
Sounds like what my piano teacher does when he makes me practice for my recital.
He pokes you in the shoulder while you're practicing?
Tries to distract me so I don't get distracted if something happens.
Oh, okay. Well, I mean, I guess that makes sense.
Tiger Woods' dad did that when he was golfing.
Really?
2 things in his backswing, just to be like, you gotta be focused. So do we mount this once we have the pins?
Yeah.
in?
If you go through, I don't know if you're going to need all that, but if you get down to the end and you're like uncomfortable with getting the iron near your fingers, you can switch over to using the spool. I just ripped that off so you and Gordon could both be working at the same time. All right, do you feel like you got this under control, or do you want me to stay look over your shoulder?
I have this.
All right, well, you're doing a great job, so just keep it up. And let me know if you have any questions. Over here. So the short ones will probably work for everything you need, but if you want, there's some longer ones down in there too, if you'd rather. All right?
You made like electrical tape?
Probably. Did you already solder it?
Yeah.
Oh, okay, because I have heat shrink, but you got to put that on before the electrical tape. Let me think for a second. I think electrical tape might be in the other room. Did you have a question? I'm sorry, I didn't hear what you said.
This pin isn't going on my end. Yeah.
I
I redid one of the pins. I got a little crimpy thing.
Okay.
I did it.
I mean, the opening isn't big enough for 2 wires, so that's why it's not going in.
Should I? Oh wait.
Well, so I put the video in the Discord if you want to watch it on your own, or you can probably get these guys to rewind that if you want to actually watch the video. But so that's the pin on the Raspberry Pi and what it connects to. One of the things that I talk about in the video is how the pins on the Pi are numbered, because obviously that matters. So there are 40 of them, okay? Maybe? I actually don't remember. But anyway, this is pin number 1.
Okay.
Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, all the way down to 40. So when we say pi pin number 7, that's like 1, 3, 5, 7. So it's the fourth one in on this row. Does that make sense?
I see.
Okay. If it would be easier for you to follow the video, feel free to hop on one of these computers and pull it up. It's in the Discord, or I can help you find it on YouTube.
Yeah, I think just the spreadsheet should be fine.
Okay.
I think.
Cool.
Which one is the first step we're running? Oh, left. Okay.
Yeah, it's left and right. So.
The board. It is in the hole. It's fine. It cannot come out because it's already soldered in the hole.
Still looking for electrical tape. I found a roll of high voltage electrical tape, which is like awkwardly thick. It's like super thick rubber stuff.
Fine if this one's sticking up.
Yeah. Did you maybe?
Pushed it through when it was hot.
Yeah, that's funny. I mean, you can fix it by heating it up again and pushing it back through. Just don't burn your finger.
Yeah, that's the issue of pushing it through without burning my
Right. Yeah. I mean, you could. I mean, it also depends on how much you care. But like, if I was gonna do it, well, probably what I would do is I'd take it out of the vise, heat the pin up, and then press the whole thing down against the tabletop so that the pin is pressed by the surface of the table. What's up? Oh, nice. So,
Pins towards the front or the back?
I can't remember. Are we putting pins towards the front or the back?
Did it towards the back.
Let's go with
There's
that.
more space.
Yeah, I think that makes sense. That looks excellent.
Solder.
They're even straight. Look at you. That's like pro. Great job. So to mount this up on the frame, you're going to have to drill these out a little bit if you haven't already, so that you can get screws through there. Does that make sense? You haven't done that already, have you? Okay, cool.
Can you do that part?
Sure. Are you doing okay? You look a little tired, maybe.
Yeah.
All right. I'm just going to do the opposite corners. You only really need two. Unless you decide you want them all drilled out, and then I'll do them. But. There you go. Yep. So I'll just explain it to both of you at the same time. So I show it in the video. So if you need more info, feel free to watch it there. But what you can do is take 3 of these and separate them, and then cut them in half, and then, well, 2 on one side and 1 on the other gives you a Y splitter.
Yeah.
right? And you do that twice, you've got 2 Y splitters. You can use one for a 5-volt pin to both steppers and one for ground to both steppers. If you want more distance than that, like if you think that's going to be too short, you can use one of the longer wires. But I think when I did it on my, you can use one of these. But when I did it on mine, I think I used the shorter ones and it was fine.
Yeah.
Mine do not.
Oh.
Look at how nice.
Longer just for safety.
Yeah, whatever feels good to you. Who has not soldered their Y connectors yet? I have some heat shrink tubing that might make your job a little easier. If you can not do what I always do, which is screw it up by forgetting to put the heat shrink tubing on before you solder it.
Well, I did it the bad way. So.
The bad way?
Yeah, I have little towers.
Oh, you could just put heat shrink over the end of that. Yeah, feel free to do that.
Okay, what's our next step?
Are you all wired up?
I am wired up. I got look at these little dual.
That is so slick.
It is slick. I'm very proud of how they look. Just put yours in the middle. So, well, but
He goes his own way.
yeah,
Yeah, right in half. All right, so if you guys want to use heat shrink tubing, as the name implies, it's tubing that shrinks when you heat it. And so, in the case of the Y splitter things, you need to put the heat shrink on before you solder the joint so you can slide it up into place. You can't really get it on afterwards. So if you need help with that, let me know. I'll kind of walk you through that.
You have the code.
It's done.
Yeah, pretty well. You can always unsolder it, but that, that's just frustrating. So,
Is this the software right here
what are you talking about?
on the screen up there?
Yeah, but you need to get the Pi fired up first.
Okay.
So let me give you a memory card. It's okay. I have many of them.
Whoa.
You guys coming a mile away.
my card is a straight up SD card reader, so.
What?
Do you have the bigger version of that?
Yeah.
Because then I can just slip it right into my computer and download the files directly.
You can, but once you boot it up, it's going to join up to the wireless network, and then you can just do it on the Pi. Yeah. But you can still have one of these if you want. With the thing. All right. Yeah. All right, Jack, you are number 5.
I'm number 5.
It says it on the label.
AP5.
So basically, there's USB, USB Type A to micro USB cables in the top right drawer over there. So you can plug your Pi into your laptop or whatever and power it up. If you don't like any of those colors, there's black ones in here. I think they're black. I don't know. Just use whatever you want. What's that?
My corner of sponge.
Where did there was another one of those little scrubby things. Where did that walk off to?
I don't know. I looked for it.
For at least 35 seconds.
Yeah.
At least like 3 seconds.
I started. There is 2, which is the correct. USB power in.
That's probably the one you want if you're trying to power up the Pi.
Oh,
Can I have one of those fancy memory cards?
You may. You're number 6. Oops. It says so on the label.
It does.
I spent hours making all of those memory cards for you guys. I hope you appreciate it.
Are they preloaded with the software and stuff? Like, is that a slide put in?
Sorry, say that again?
Do I just put it in, or do I have to load anything onto it?
No, you can pop it in, and then there's USB cables over here.
whatever's on it is up.
The stickers up?
The wording is up.
The orange.
Yeah, right.
Nice. So those plug into the stepper drivers, which go here and here. So a little trick that this is totally optional. Sorry, I totally pulled that out of your hand. Is you can, if you don't want, if you want to do a little cable management, like, custom PC building style, you can run the cables around and over, or you can. You might be able to get 2 winds out of it if you go the right direction, but this just takes up the slack, right? So if you go around like that, then that's just about the right length to plug into the stepper driver, okay? So, and then these, I think they go on like, yeah, the holes line up like that. So one here and then one right over here next to it. This one's a little more complicated, but if you need a reference to look at, that's what it looks like.
Which way should I know? And what is this piece called?
That is the stepper driver.
Stepper driver?
Yeah.
Okay. And does it matter which way I mount it?
No, as long as the wires reach. I have it mounted the opposite way that you do, but I mean, it's like the difference is millimeters. Since the wires are running from these pins to the Pi, maybe it'd be a little better.
Because it's further away from
Yeah,
the wheel.
yeah. If you don't have it totally locked down yet, I might swap it over. Okay.
So you just have to flip.
Yep. Yep.
Boy, I really should have Fuji and cleaned out that electronic room after school.
Yeah.
I was there for just a little while.
Okay, what would you want to have powered, Jeff?
So the way that OS image on the SD card is set up, as soon as it's done booting, which might take 30 seconds or so, it should start advertising its own wireless access point. And the name of it is going to be something like LoisLab-AP, whatever number is on your memory card.
LoisLab 5G?
No.
Is the network you're currently on?
Well, first of all, is the Pi booted up? Is it got a green light and all that?
Yeah, it does everything with a green light. Yang 2020. Why is there someone in this building that has Wi-Fi
Probably
that
the
says
same person
Yang
with
2020?
Because the Portsmouth office for the campaign is down the hall.
Oh.
That makes sense. I thought someone was just like,
Nope.
Good way to advertise to younger people.
Well, they didn't coordinate anything with us.
Right.
Although, given how much he talks about artificial intelligence and machine learning in his stump speeches, you'd think that maybe he'd walk down the hall and talk to us. But I don't know that he's ever actually been in this building.
I'm sure he'll be here at some point.
Well,
it'll be here.
are you sure?
I am thousands.
Am I gonna walk over there?
Oh, it's here.
So the answer to the question is yes.
You know, if you went down there and introduced yourself.
It's
said,
asking
"Hey,
for a
here's
pie,
who we
just
are, and
notice."
here's what we do, you never know. They may want to walk down here and see if they get a little shot on paper or something.
Maybe.
You guys seem pretty proud.
So the people who work on the campaign, they're always on the phone, like, talking to donors and stuff like that. And they're always sitting out in the hall, like making these phone calls. And so one day we just went out there, we're like, do you guys want to use our room so you're not sitting out in the hallway talking on the phone the whole time? Because during the day, the classroom's usually empty. So they've used it a couple times.
Hey, what's the password?
For what?
Pi, take a guess.
For the wireless access point? LoisLab. I apologize for that, but it needed to be a certain length. And basically every password that has anything to do with LoisLab, I try to make it LoisLab.
Bouncy boy. Alright, I'm connected. What do I do then?
Panic.
Ah!
Good job. Do you type in what? So
What IV do now?
if you point a browser at,
Wait, can I connect it with my phone?
yeah, you could. That should work.
I forgot my laptop.
What do I do?
I'm coming. All right, so you connected to the wireless access point? Okay. So I think you can point a browser at the Pi, which should be 192.168.4.1, I think. Actually, put a colon 8000 on the end of that. I apologize, guys. I have a document on this, but it's a little out of date. And LoisLab.
Okay, wait, so the IP is,
So did you connect to the access point?
yeah.
Okay. So the IP is going to be,
192.
192.168.
Wait, 168?
Yeah.
Do I want the control, right?
No, it's just loading up the thing. That's just giving you
168.
4.1 colon 8000.
1.
I'm going to put that on the whiteboard.
And the username is.
It's LoisLab, and password is LoisLab.
Working bit or
Is it steppers or stepper.py that you want to shove in there?
Are you, what are you looking at the GitHub
Yes.
repo? You can actually, on the Pi, download the whole repo.
Wait, how are you doing this?
How do I do that?
Yeah, it's loading.
The pie is there. So why? Yeah, give me 1 second. Oh wait, there's motor stuff already there.
Yeah, I don't know if it's the right stuff.
So you gotta just connect.
Motor.py
Sort of
there.
lock when it gets there. Yeah, so.
That's the only thing that's there though.
What if I run,
Okay, so
like, grind or anything? So I'm at the terminal.
cool. Okay, so are you doing it from your phone for the fun of it?
I forgot my laptop.
Okay, you could hop on a computer. What's that? The side of the soldering iron. Don't use the tip, but just heat it up with the side. Let's see. Can you, Jack? Can you cast up here?
Actually, I probably should do it from the computer. So I've been down
It might be easier.
I can just copy the GitHub.
But if Jack casts it up here, I'll just walk through it with you really quickly, both of you.
Says no device is found.
You make 2 lines.
Yeah. So if you take 3 and cut them in half, that gives you the.
Yeah, we're not on the same network anymore, so you can't count.
Yeah.
Okay.
Also, I can't get the GitHub thing because why? I can't go to the internet.
That's okay. The Pi can. It'll make sense in a second.
I can go straight to GitHub because I had it loaded before.
Okay. So let's see. Let me hop on. Oh, this doesn't have wireless. So
Let's see. If I just do Control C and I just locate in a file, near file, move.
Now, did you have a wire stripper to strip the end of this?
yep, there's a set on the table over there. Okay, so I can put it up on the screen, but I need to see something first. Can you, in the little command prompt here, type host name? LoisLab, LoisLab Pi-05. Okay.
Host name.
So what was it again? LoisLab Pi what?
LoisLab Pi.
It's not returning anything to me.
Okay. So Jack, this is your Raspberry Pi up here.
Oh, you're looking at it too?
Yeah.
How are you doing that?
Magic. So the way I have these configured is when you boot up the Pi, it joins our wireless network, but it also advertises the access point at the same time. The reason I did that is because when I taught this class before and I had like 10 people all booting up their Pis at the same time, it was impossible to know whose was whose. So they all advertise their own access point, like you're 5, he's 6, whatever, so everybody can connect to their own. But they're also connected to the wireless. It's just a lot less reliable to connect to them that way. So anyway, what I wanted to show you, though, is this is a little, I wish that was bigger. Hang on, let me see if I can make this.
You booted me off as well.
OK, sorry about that.
No, don't worry about it. You go on. Oh, no, now I'm here. Now you didn't.
Terminal's in collaborative mode. I don't know what that means. But anyway, so yeah. OK, so we need what I posted in Discord. So let me just hop on.
I have it up.
Do you?
I do. Just what part of it do you want? Yes. Like the rover, the stepper.py, stepper.
No, in the Discord, I want you to grab the URL. It was blah, 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 whatever, .git.
It's not popping.
It's all right. I'll get it.
Yeah, I'll just let you. I'll let you set it up.
I don't know who I'm logged in as right now, but.
So can I still use the internet on only? Can you only use the internet through the terminal, or is
Oh, so it's not you up there.
Can you only use the internet through the terminal?
or is connected to that access point here allowing me to use the LoisLab Wi-Fi?
Yes, both of those are true.
Yes and yes.
SD cards?
The answer.
There's a little pile of them right there. Try to find the next one in line. I think number 7 is probably the next one.
That looks to be 7, yes. What you do?
Okay, so. Okay, here's the Git. Okay. So if you go into the. Oh, I'm not sharing that. I apologize.
Wait.
So in the Discord, the Git address is right here. Okay. So it's github.com, michaelmcgill@qbotrover.git. So if we hop back over to the Pi, the way this works is, so I'm currently in the dev directory, right? So on the upper left in the tree, the dev directory is like the root. For any of you who haven't played around with little Unix computers before, you'll learn some commands as we go. But basically, little tilde, the little squiggly is your home directory, /dev. That's the dev directory where this, like, all of the stuff is in the tree on the left-hand side there. So if you want to copy that Git repo down, there's a command built in for that. And it's git clone, whoops, and then the address. So I've got git clone and then that URL that I posted in the Discord. And when I hit enter, it's going to go out to Git and pull those files down for you.
Is that built in
Git?
to the Pi? Yeah.
Yeah, it's part of the OS.
Wait, so it's
CD. And does that work for things that aren't GitHub, or is that just for stuff that's on GitHub?
Well, git clone specifically is a client. Git is specifically a client for GitHub. And there's other ways to download things. I mean, you can download whatever you want. But if you get into doing a lot of code here, it's a good practice to sign up for a GitHub account. And then when you write code, you push it up to GitHub. And that's like your online repository. And then you can share it with other people or pull it down wherever you need to. And it also does version control, where, like, let's say you're working on some cool robot code and your buddy is collaborating with you. They can pull down a copy, do their mods, and then push the changes back up. And then you can refresh your copy of it and pull down the changes so you can collaborate that way. So, yeah.
it will like allow me to copy from outside.
Yeah, you can just come and use this computer if you want.
I'm just already here though.
Yeah.
It's more of the
Is your
novelty.
account actually private and you're setting who's sharing, or you put it up there and you can search?
You get to decide. So a lot of people share their stuff.
Right.
Like there's a huge volume of open source projects up there. But when you create a repo, you decide if it's public, private, or shared with select individuals.
And you can use select parts of it that are shared, or is it like either shared or not shared?
You create a repo, and I think the permissions are repo by repo, but you have an account, and you can have an infinite number of repos under it. Yeah.
So you can just create a repo.
Yeah.
A shared repo, and you can have repos that are just yours.
Yep. Yep. Yeah.
Can I use that computer?
Yes, you can. Guys, I didn't realize what time it is, though. It is very close to 8:30. So the good news is, though, is that we're right on or ahead of schedule, like for the stuff that I wanted to cover. You guys are killing it. So if you didn't get to boot up the Pi this time, like that was actually something I wasn't necessarily thinking that we would get to do until next class anyway. So you're totally fine. But oh, nice. That's pretty cool. Like if you're going to be controlling your robot from your phone, like that's pretty awesome. Yeah, well, and that's you remember the thing we were playing with last class? Like Michael just put together a quick web page that was hosted on the Pi that had the links that controlled the moves. So you could easily do that.
Wait, now it's set up. Can I just, what command can I put in to move a step mover?
So if you downloaded the repo, and if the thing is wired the way that you intended, then, or the way that I intended, maybe is a better way to put it, the file that you want is rover.py. If you run that, you can just hit run up here. Hey, look.
Try to select it.
Well, you're not getting any traction. But, you know, we can put some rubber bands on the wheels.
And it's just trying to move in like a circle?
Yeah, what it does is it goes forward, turns, goes forward, turns, goes forward, and turns and goes forward. So it does a box, basically. But that's just like a quick demo. Right? All right, Jack's the first one to make his robot move.
What's stepper.py?
So stepper.py is a little library that I wrote that just takes care of the stuff behind the scenes of sending the pulses to the motor. But you can pull it open and see how it works. It just makes the code a little bit more streamlined in Python when you import the stepper driver, and then you just create an instance of a stepper and send it commands. The intent there is not to hide any of the code for you, but just make it a little easier to kind of read what's going on. So feel free to dig through that code. It's not guaranteed to be good. Like I hacked it together in an afternoon, you know, but it's there for you.
And so if I connect to the normal internet,
Yeah.
I could do the same thing.
Mine tries to do something.
So if I go to this computer over here,
Yes.
and I do beep, Bob,
Yes.
Bob,
Yeah, that's connected to this. Yes.
in here.
Yes. Because the Raspberry Pi that's controlling your robot is also hosting that coding environment. And so it doesn't matter if you connect from there or your phone or that laptop or whatever. You're talking to that Pi and running code on that Pi.
If I want to go to Jordan so he can try it, see if it works,
Yeah.
how would I go to his instead of mine?
Well, the easiest way would be to connect to his wireless access point and connect the exact same way you just did. Everything is the same except you go to LoisLab AP-6 instead of 5 and do the same thing. Okay.
I didn't grab a message, but I'll get one next.
Yeah, that's totally fine. So Jaden, why don't you pack your stuff back up in your bin and put it back on the shelf, and you should be good to go.
Should I just keep
Yeah, you might as well hang on it for now. But that's awesome, man. You got that all soldered up, and next time you'll get it moving. That's awesome.
There we go.
Thank you, sir.
You are very welcome. I'll see you next week. Awesome job, guys. We got robots starting to move and everything. What's next? Hacking on code, I guess?
Now it's time to make an arm.
Now it's time to break them by
Jack,
telling them to
joke's
do
on you.
something.
Jack's gonna build a 3D printer.
You know, there's a lot in common between these silly little robots and 3D printers. So that's not all that crazy an idea.
Cost less.
So wait, if I wanted to connect to just
Oh, I put the idea in his head now.
my box.
Thank you, Jeff.
Really helped
Sure
me
thing.
succeed.